Hello, my name is Mathews. I'd like to start by thanking the Indonesian Ministry of Environment and Forestry for their continued support of conservation and for agreeing to meet with me today. Today I'm going to be presenting a compilation of a variety of surveys regarding the order Rodentia across 5 Indonesian islands. For an overview of the data found across all 5 islands, 585 different individuals were found comprising 18 different species. One species that was previously thought to have gone extinct in the Holocene era was found on islands 1 and 3. This is a very important finding, which I will discuss more in the future. 3 near-threatened species were found and 3 vulnerable species. To continue on with that discussion, a few of the key species that were found overall, of course, that first one is Alormes aplani. That's the large rodent species that was originally thought to have gone extinct in the Holocene era. It was originally discovered by fossil remains and identified as a distinct species based off its molar structure. Again, that one individual of that species was found on both islands 1 and 3. Maxomys dolmani is one of the vulnerable species. Maxomys whiteheadi and Rattus rentjanus those are the 3 vulnerable species that were found in this study. Before I get into the individual data from each island, I want to briefly go over a few of the terms that I will use to quantify that data. The first is species richness. This is simply the different number of species present on the island. The second is evenness, and that is the relative abundance of the different species on the island. Unique species I have defined as a species that was only found on that island of the 5. It could be used interchangeably with endemic, but as this survey only focuses on 5 islands, it's difficult to know if they're actually endemic, so I call them unique species. And the Shannon-Weaver Index is a way to take into account both species richness and evenness. It's another measure of diversity. So now to get into the data that was found from each of the individual islands. The first one is Island 1, that is the largest of the 5 islands. Because of this, it was very species rich. There were all 3 vulnerable species that were found were also found on this island, and that they comprised of 19 individuals. Total individuals found were 265, 16 different species. That evenness value is 0.588. 4 unique species were found. Again, that's 4 species that were not found on any of the other 4 islands. And then the species diversity per kilometer squared is a way to measure the density of diversity. And then, of course, that Shannon-Weaver Index value for this island is rather high at 1.32. I wanted to take a moment to include the individuals that were considered unique species on this island. The first is the Flores giant rat. It's a near-threatened species. The second is the edented Sulawesi rat. It was only discovered in 2012. It's the only known rodent that lacks molars and specifically eats worms. The conservation status of the species is unknown due to its recent discovery. It is classified as data deficient. The cream-colored giant squirrel is near threatened. Adults can weigh up to 2.6 pounds, and the large bamboo rat primarily eats bamboo roots. For Island 2, it is a much smaller island. There were much fewer individuals found, only 6 different species noted, no unique species on this island, and a much lower Shannon-Weaver Index. Island 3, again, is the second largest island of the 5. It once again had all 3 of the vulnerable species were found on this island, a few fewer individuals than on Island 1, with the total coming in at 156. 12 different species were found, and again, a very high Shannon-Weaver Index. Island 4 only had 4 individual species found, and a relatively low Shannon-Weaver Index, and no unique species. Island 5 is the smallest of the 5 islands, and it's the one that's located far away from the other islands, as you can see on the map. It had only 3 species found, but 2 of those 3 unique species were unique and not found on any of the other 4 islands, and it had the highest Shannon-Weaver Index. Those 2 unique species that were found on Island 5, the first one is the Malayan porcupine. Its diet includes roots, tubers, fruits, and leaves. The second one is the Musschenbroek's spiny rat, and it is endemic to Indonesia, so this is a very important species. One important thing to note about Island 5 is it was the only island of the 5 that was not found to have a population of Rattus rattus. Rattus rattus is commonly known as the black rat, the house rat, or the ship rat. It is one of the most highly invasive species in the world. It is a serious threat to island biodiversity. This species is detrimental to native birds, reptiles, and small mammals, as it eats eggs, chicks, and even adult birds. Preys upon many of the native reptiles, and many of these species evolved as island species to not have natural predators. And this is a very important factor to consider in terms of conserving Island 5. In terms of analyzing the data that was found on each of the individual islands and using them to compare, what I've done is I've taken the different values on the left side, the different calculations that were made, and I have ranked each of the 5 islands based off of them. I have then totaled up the rank, divided it, taken the average of it to determine the mean rank. The lower rank is better. As you can see up here, the vulnerable species abundance, Island 1 has the most, therefore it is ranked at number 1. Based off of this, you can see Island 5 has the lowest value at 2.29. Island 3 is second lowest at 2.71. Island 1 is an even 3. And then Island 2 and 4 make up the last 2. I want to take a moment to go over an analysis of common patterns that are noted in regards to species diversity and abundance. The first one is the latitudinal gradient. That is where the species diversity increases as you move closer to the tropics. This was unable to be evaluated due to the fact that I was not provided with the data on where these islands were in regards to the equator, whether farther north was closer to the equator or farther south. As the equator runs right through Indonesia, it was difficult to know. Second one is elevation gradient. Once again, I was not provided with elevation data, and on islands this is not as much of a factor, but typically this is that species diversity tends to decrease with increasing elevation as a result of weather extremes and other factors. The third pattern is species area relationship. This is where larger areas support greater population size, including the total abundance of species. So again, that species richness. In this one, I was able to compare, and I've done so on the next slide. This is the graph of the species area relationship. As you can see on the x-axis, I have island size in square kilometers. On the y-axis, I have species richness. And as you can see, that line, though it's not a straight line, it is constantly increasing. As you move farther right on that x-axis, you move up on the y-axis. All the way to the far right is that Island 1 that is 92 square kilometers, and it has 16 species on it. And so this data does support the previously noted pattern of the species area relationship. Coming back to this pattern analysis, the next one is the habitat diversity or habitat heterogeneity hypothesis. This is where a more diverse habitat and plant structure and soil types lend to higher species diversity. This was unable to be tested due to me not knowing the structure and the makeup of these islands. The common patterns of abundance. The first one is that most species are rare, few are common. This was able to be tested, and I have done so on the next slide. Here I have created a rank abundance distribution in which I have ranked the species from 1 to 18, 1 being the most common, 18 being the least common, and then I have taken a log base 10 of that abundance, and I have plotted those points. You can see that this data does support the idea that most species are rare and few are common, as a majority of the species are in this tail region. Coming back to these patterns, the second pattern of abundance in which common species tend to be widespread and rare species tend to be restricted in distribution. This was found to be the case for the most part in this study. The majority of the species that were considered unique species, in which they were only found on one of the 4 islands, there were only 1 or 2 individuals found, and the individuals that were found to have populations of 70 or even over 100 on one island were also found on other islands. This final pattern that species tend to be most abundant at the center of their range, I was not able to test this. I do not know the geographic ranges of the species, and I do not know their ecological niches to evaluate the centers. My final recommendations for which islands to conserve based off of all of this data is islands 1, 3, and 5. This brings a total cost to 420 million rupiah. I've also advised and recommended a 10 million rupiah exclusion program in order to ensure that the black rat, the Rattus rattus, does not become established on Island 5. Once again, this is still under budget. Just a few important notes to consider as I end this presentation is that these conservation recommendations only consider the relative abundance of the order Rodentia. It does not include other factors, abiotic factors as soil, terrain, geological features, or other biotic groups. And I highly recommend that you meet with my other peers in this agency that are studying the conservation strategies according to other taxonomic groups. Thank you for your time, and I wish you the best of luck.